All right, here's example one, which I mixed up examples with the previous video. I did example two first, but that's okay. Like to mix things up a bit, right? So in example one, we have a polynomial function. So we're going to state the domain first. The domain is all real numbers. So it's always good to think about, especially when you're trying to find points on a curve. You want to know what should you be excluding. And you can see the picture here that all, it's defined for all real numbers. And our goal is to find any local extrema using the first derivative test. And to do that, I need to know the critical values. So that's my step one, determine all the critical values in the domain of f of x. All right, and so let's take the first derivative. That would be 3x squared minus 12x plus 9. All right, and so I want to know all the critical values that are in the domain of f of x. So therefore, since everything's in the domain, I don't have anything to exclude, but critical values where this is equal to 0 or undefined, it will never be undefined. Let me divide by 3 to simplify finding the roots and factor. And so there are 2 zeros in this function. So my critical values are at x equals 3 and x equals 1. Now, so I found all the critical values. Now I'm going to use the first derivative to test around those critical values. And if my first derivative changes sign from negative to positive, that means I have found a local minimum. If it changes its sign from positive to negative, will have found a local maximum. So let's do our number line test. And I place those two values on my number line, 1 and 3. And there I go, changing the page again. Okay, so remember that we're to pick values around that. So how about if it picks 0, 2, and how about 4? And we're going to evaluate the first derivative around those values. So I'm going to do f prime of 0. So that would leave me with 0, 0. That's going to leave me with 9, which is going to be a positive number. So this is positive. So that means that, let me just write what that means. So that means that in this interval, on this part of the domain, f is increasing. All right, testing the next interval from 1 to 3, we're going to choose 2, f prime of 2. All right, so I substitute that in. I can do it here, or I can do it in the factored form. You know me, I like to use the factored form. So in the first factor, 2 minus 3, well, that's -1, so negative. And then 2 minus 1 is +1, so that's positive. Negative times a positive is a negative. So negative here. And then at x equals 4, I test the first derivative. So f prime of 4, and so that's going in 4 minus 3, that's a positive. And then plugging into this 4 minus 1, that's also a positive. So now my first derivative is positive when x is equal to 4. Okay, so what do these mean? So remember that with respect to f, in the middle section, my function must be decreasing, and my function must be increasing again. So I have my function, if I was to draw it, it should be increasing until I get to 1, then it should be decreasing. And remember, these are where the derivative equals 0, so we actually get a horizontal tangent there. And then decreases till I get x equals 3, and then it starts increasing. And you can see that modeled right here. So this is at x equals 1 right there. And then at x equals 3, here's my graph. There's the horizontal tangent, and it's decreasing in that region, and then it's increasing again. So you see how you can sketch it just by doing an analysis, and you get precision in numbers. All right, so now let's determine any local extrema using the first derivative test. So answer the question, right? What's the question? So we've talked about domain, check, And now I have to answer that. So what are my local extrema? So it looks like I have a relative or a local maximum at x equals 1. Relative max is at x equals 1. And a relative, so this is a relative minimum at x equals 3. I'll just abbreviate that, relative minimum at x equals 3. All right, can you give a reason why? Well, remember that we have to do that on the free response questions. So we really state that the reasoning is right up here for you. So why is x equals 1 a relative maximum? Right here. It's a relative maximum because f prime changes from positive to negative. So I want to say that. See right here, we have f prime changes from positive to negative. And so because f prime changes from, and we can literally write the sign positive to negative. So that is allowed to write that. And we have a relative minimum at x equals 3. Why is that a relative minimum? Because the first derivative changed in sign from negative, or so the function was decreasing, but that's because the first derivative is negative and it changed to positive, negative to positive. Because f prime changes from negative to positive. It's not good enough when you're answering these questions to just say it changes sign. Changing sign does indicate a relative extrema, but it doesn't pinpoint whether it should be a max or min. Changing from positive to negative tells us it's a max. Negative to positive tells us we have a relative min. So you can't just say changes sign. Okay, that's this example, and we'll continue with another one on another video.